Hey everyone! Wow, it's been a while. A while back I made this video about this frog rig, and I showed off these sort of controls that I made, specifically right around the sort of in-between joints. So they're on the forearms, the upper arms, and they have a bunch of sort of things going on that are pretty cool. And I set it up so that it's just a generalized spline rig that you can put anywhere. So this is also on his spine and his legs and all that. And it's a pretty cool sort of setup, and it gives you a lot of sort of power over the shape that you might want to be going for if you're doing some sort of kind of loop-de kind of animation with rubber hose sort of arms. This is a good sort of setup. And I promised you guys in the description of that video that I would show off sort of the rig itself and show you guys a tutorial, and so that's what I'm going to do. But just so you guys know, the tutorial is just going to be about this sort of center part, the position, the scale of this sort of part in the middle. And the rest you guys can probably either figure out on your own, or I would also suggest Jordan Harold Paulson's site riganimator.com for getting most of the controls of that procedural ribbon figured out. That's how I learned it originally, and it's not a bad way to go about it. He knows his stuff. So yeah, basically I don't want to reiterate too much of the conversation. I'd like to add something new to that sort of point. So I'm going to talk about just this middle control. And this middle control is pretty nifty. This is the underlying rig. This is the ribbon. The basic gist of why you would make a ribbon out of a NURBS surface is so that you can get a lot of the deformation stuff going that you can do with meshes onto your joints. So if I display the joints here, you can see there's a joint, 12 joints across this thing, distributed across. And actually, so I'll tell you where the joints are. The joints are under these follicles, and these are like hair follicles, so they follow the surface. So if I show the LRA and I move this, you can see it's kind of pointing outwards according to the normal of the surface. So if I twist this, I twist along with it, and you can twist a bunch. So it's pretty easy to set this up. This one is just there's a blend deformer on this surface. If I go into hide that, take the surface here, you can see that there's a blend shape, and each of these are all set to 1, so they're all on, and they come from these surfaces here, and these all have different deformers on them, and they're otherwise static. So it adds up to the shape that can do a bunch of different stuff all at once. So that's kind of cool. So yeah, that's how that's sort of done in a nutshell. But like I said, we're just going to do this one little part here. Okay. So it took a while to get this video out because I actually have learned a lot since creating it, and I've been sort of messing around with it because I found out pretty quickly after I made it that it runs pretty slowly if I key this position and do the same thing with a bunch of different controls. It goes down to 5 or 10 frames a second, which isn't really that bad, but if it can be helped, we should make this less of a monster, because it is a small part that will be thrown in a bunch of places. So this is the spaghetti that you get. So yeah, what's sort of happening is there's a bunch of just separate versions of each of these, and they're all going into each separate point. And to a certain degree you do have to have a little bit of that, but eventually they all add up and then get put into one cluster, and that's pretty inefficient. So we're going to narrow this down a little bit and make it something that you guys can actually use. So yeah. Under the surface, this control is just a bunch of clusters that are weighted based on the values of a color ramp in my texture ramp. So I can display that ramp. One of the cool things about this setup is the NURB surface goes from a 0 to 1 ratio, and the ramp goes from a 0 to 1 ratio, and the follicles go from a 0 to 1 ratio. So it's actually pretty nice. It looks good. If I switch this to mid for the ramp display, it'll project the ramp color based, it'll project the ramp along the surface here. So the white area is being affected the most, and the black area is being affected the least. So if I clamp this in, you can see sort of what's happening. And if I switch this from a bump to a smooth, you can see it's a little darker along the edge there. And if I do a spike, it's the same sort of thing. And what I have here is two different ramps that blend between the two of them, so I can sort of animate the difference here and just switch any of these. So yeah, I also have that for the ends. It's set up slightly differently, so I'll show you really quick. For the ends, I have it set up to be just the opposite. So white is connected by this control, and black is influenced by this control. And if I change this blend to like that, then you get sort of a different sort of interaction on either of these ends. So if this were like a spine, you could sort of see how this might be kind of fun to have as an option. Or if he was sort of more stick in the mud kind of guy, maybe this is more your style. So it just changes the way the animation might come out this way, which is kind of nice. I think it looks pretty good. So yeah, this works really well. And I think it's a nice sort of elegant way of doing this sort of thing. So I hope you guys enjoy this. As a kind of additional point to why this is an elegant system, you can actually change the way that the follicles behave independent of the way the rig behaves. So if I wanted to sort of scooch this around, it doesn't really matter what the rig is doing. It just sort of follows on top of this. So if I break this and move it, I can do that pretty easily. So you can have some sliding effects going on along with this. It's sort of like an additional layer of stacking that you can have. And one of the things I have in here is a way to distribute the follicles depending on how many I need. So I can actually increase this value or decrease it depending on how many joints I need to make good looking deformations, because that can change pretty easily. Another thing is that you can actually have it sort of stretch. You can actually figure this out. There's a way to sort of have it stop at a certain point, and then you get more of a sort of parametric IK look going. And that just sort of involves setting the range to how far this distributes down to a certain value. Okay, so let's get started. First thing I'm going to do, here we go, grid options. Okay, we're going to do 10 units long and then 3 subdivisions, and that just makes it a little easier to grid snap stuff. And we're going to create a NURBS primitive plane, and I'm going to have it 0.25 width. This could be anything, 3.5 or whatever, but whatever. 0.25, length of 10, cubic, 1 patch in U, 30 patches in V, and apply. You can't see anything, really, can you? So I'm going to really quickly turn on my hardware fog and set this to 10,000, and then set the color to something a little more visible. There. Good enough? Okay. That's a neat little trick. Sometimes. For tutorials, I guess. Okay, so what we're going to do is we're going to rotate this so that it's pointing down X. So if I clean this up, if I freeze transformations and delete my history, X is pointing this way, Z is pointing this way, Y is pointing up, so that's good. I actually, in this, a lot of this is sort of setting it up correctly the first time because it's one of those rigs that you can use anywhere, and you may do so. So what I'm also going to do is sort of a something that I have decided was a good idea at some point, is have Z point outwards to, in the direction of the normal. That kind of makes sense to me. So X down this way, Z down this way, Y is up. I don't know, just makes sense. Okay, so what's going on here is I'm also putting it at the origin like this. I'm going to have this replace joints in some cases. So if you wanted to script an implementation of this script, of this rig, then this is a good place to start it off, I think. So that's sort of why I'm doing it this way, and we'll call it ribbon surf. Okay, so at this point, if you wanted to create joints, you could really quickly go to FX, N hair, create hair, NURBS curves. We're going to do one count, U count, going to be 1, V count, we'll just do 6 or something, whatever. And then we'll set static to new hair system, apply. And we'll delete the nucleus, the curves, and the hair system, and we'll leave the follicles. This is going to be our joints, group, whatever. And then on each of these follicles, you'll notice there's a curve, just an empty transform underneath. You can select all the follicles, hit down and then to the right, and you can see that the curves are all selected. Just hit delete. Yeah, and you'd rename these. But I'm just going to go really quickly. If I type joint into Mel while selecting these, it'll create a joint underneath the transform that you're selecting. So if I hit G on each of these, I have joints. Ta-da! And these joints are already set up to follow the thing. So I can skin these joints to the eventual mesh. So yeah. And then you can add all sorts of other things, other deformers to this as you need them. But like I said, we're just going to do the middle control. And the way this is all set up doesn't actually require that it be a surface or a ribbon setup, because all I'm going to be messing with is the effects of a curve, of a cluster on a CV curve. So you could do this with a regular spline IK. But we're going to do it with the surface because you get the feedback with the ramp texture. So we'll do that next. We'll make the ramp. I'm going to hide these joints because they're in my way. But node editor, and we'll just type in ramp texture, and then we'll just really quickly apply it and turn that on. Cool. If you find that the white side is, go away. If you find the white side is on the left, like if it looks like this, then just turn it around, set your pivot point correctly, and put it back. You want to do that before you do the rest of it, because otherwise it's pretty difficult to go back. And we do it this way because it just follows the attributes of the ramp and makes more sense. And that way we won't get confused. You can see that it works correctly. So what we want to do is have this white area be in the middle, and have another thing here for the black area. I'll put this right at 0.5. And this will be the weight of our control for this curve that we'll make next. So we'll put this here. Did I do that right? No. Holding X, we click here with set to linear, hold X, click here, hold X, click here. We have our 2 points. I'm going to really quickly make a layer for this so that I don't have to try to select this and fail at it. We'll call this wire curve, CRV. And I'm also going to create a quick select set for my ramp. I already lost it. This part's not really that important. This is just a little UI to create a selection set, so I'll just set. Selection sets exist in Maya already. You can just go to Windows, Relationship Editors, Sets to mess with that sort of thing, and also you can create quick select sets here, but I just have it here. So now I can just double click this and get my ramp. Okay, next thing we're going to do is redraw this curve because we have two CVs. I'm just going to actually get the curve shape here and go to Component Display and Display CVs. And now I'm going to go to Modeling, Curves, and then Rebuild Curve, and I'll set this to 30 and set it to cubic. There we go. So it created a couple of extra CVs on the ends here. We don't want those because we have to math out where it all is. You can see that they're lined up perfectly with our grid that we set up. And if you look at the edges of this, it's also lined up. That's not as important, but it looks nice, so whatever. So what we'll do is we'll grab we'll unreference the surface so that we can do this next part. And we'll do deform wire. We'll select the surface, hit enter. Select the curve, hit enter, and we're good. So now if I grab this, the surface comes with it. It kind of bends out a little bit, bows out a little bit. So what we'll do is we'll just really quickly hit the wire and hit the drop-off distance to 10. And you can get to this wire output by selecting the surface or the curve. It's right here. Okay, so now that should work. Yeah, 10 or so is usually good. Next thing we're going to do is create our cluster. So we'll grab all of the CVs and we'll go to Deform Cluster. We want it to be all of them because we want the cluster to potentially affect every CV. Not necessarily the last ones, but whatever. So now we just need to somehow map the ramp to this cluster, to the weights of this cluster. So, okay, the anatomy of a cluster. We'll call this mid control CLSH for cluster handle. It renamed this one here, so we'll just call this mid control CLS. Alrighty. So the anatomy of a cluster. We got the transform node, and this affects its position. It's We got the shape node, and that's basically just this little C here. If I go into the attribute editor at the shape node, I can just scooch it over here, and it doesn't change anything about it. It just changes where it looks like it is. And then there's the cluster itself. This is the deformation aspect of it. You can see that the position, the world matrix of this handle goes into the matrix of the cluster. So yeah. Now we have to mess with this weight list here. So what we'll do is we'll grab this ramp, which we will rename mid control ramp. And we need to somehow get the values coming out of this into this. And I don't know that there is a particularly good way to do this other than the way I'm about to show you. If you guys know of a way, by all means tell me, because this is the part where it gets a little hacky, but it works out in the end. So what we're going to do is we're going to create an expression. Oh no, an expression. Expressions are the worst. Alright, so expressions. So what we need to do. The main thing that we're going for here, well, let's create our expression first. Make sure it has something to save. create, do mid control expression. Okay, so what we're doing here is mostly doing color at point for the mid control ramp. One of the tags involved here is you can actually set the U and V values to check for. So if I set U to 0.5 and I set V to 0.5, then what it'll do is it will check the value right in the center of the ramp here. So right there where that dot is basically. So at the current point that value is 1. If I set to search here by setting U to 0.5 and V to like 0.25 or so, then it'll check for this value. So what we need to do is check for each value down each point, pretty much marked by these CVs, and set the value of the weights here to the value that it derives. So that's what we're going to do. We're going to actually have V be a variable, suppose, and that way we can loop through. So we'll create our loop for I equals 0. Okay, this is in parentheses. For I equals 0, and as long as I is less than or equal to 30, we'll add to I plus plus. So what happens for this loop, if you don't know how loops work, we start with a value 0. We will continue to do what is in this loop here as long as I is less than or equal to 30, and at the end of each loop we will add to I. And this is useful because we can actually use I within the loop, which is what we're going to do. So we can have float pose equals I divided by 30, and that will set the position. Unfortunately, it won't actually work. It will give us an integer, return an integer, so it'll be like 0, 0, 0 all the way down the line until it hits 1 divided by 1, or 30 divided by 30, which is 1, and then it'll snap to 1. So we'll actually have to add one more line here where we convert I to a float value, and have that be the value that we divide by 30. So what's happening here is each time it goes through the loop it adds 1, so we're starting with 0, start here, and we'll divide 0 by 30, and it'll set the script to ask for the color at point 0.5 going this way, and V to 0, which is right here. So that'll be black at the moment, and probably always will be unless you change it. And then it'll go on to the next point in the loop, and it'll search 1 divided by 30, which would be right about here, and then it'll get that point and the color at that point, and it'll set the value of the cluster to have that much weight there. And that way you can sort of set the color of the ramp and it'll set to the correct point. So yeah, that's the basic gist of how that works. So now we gotta do it. So we will derive our value here, so float value equals, and then we use the tilde key, which is up next to the 1, to have this be the thing that it searches for. And yeah, that should work. The reason this is an array is we can actually get several different types here. So if we wanted dash output to be RGB, then you could have float value 0, index 0 would be equal to the R value, the red value, and then G and B. And you can do some stuff with that, but we'll just use alpha. So it'll just be float value 0. Float value 0. Okay, so what we gotta do is we have to declare a variable outside of this loop called output. Call it float output array. Done. And then on the inside we have to set the value. So output I is equal to value 0. Cool. So now we're stacking this array full of values from index 0 to index 30, 29, whatever. Yeah. So now we have to apply them to the actual thing here. So we have to put them into this weights list. So we have weights list weights. So it'll look a little bit like this. Mid control dot weight list 0 dot weights 0 equals output 0. I would love to have this be a loop and just be done with it, and it would look like that, sort of. But there is no way to do this, as far as I know, with expression syntax. It's one of those weird things with Maya. They need to be written out explicitly in order for them to be sort of part of the expression correctly. You might be able to do this with a mel script, and then just sort of have the expression here draw on the mel script, but this is the only way I know how to do it. So we have to write it all out, but luckily we can actually script out writing it all out, so we don't have to write the same thing 30 times. So I have a quick script here, which just creates a loop and prints out a value. So if I cut this, it goes through 30 times and prints out mid control weights list plus I and does that thing. So boom. So here we go. We can just grab this and paste it into here, and then we're done. And you can see it created the connections from the expression and into the control. One more thing about expressions is they run all the time. They run every time Maya sort of would otherwise evaluate. So if I really quickly go in here and say print evaluating, and then character break or line break, whatever, hit edit, then you may see from my script editor here that every time I move this, it's evaluating, and it's kind of heavy. The script is, the color at point is a little bit intensive. It's not too bad, but it's running 30 times per frame, and a frame is just 24 frames every second. So that if there's no reason for it to run, we don't want it to run, if possible. So that sort of keeps our overhead down a little bit. So what we'll do is we'll get rid of that line. Well, we'll leave it in so that we can test how it works. And we will switch this to on demand. So by the way, you can see now it actually does work. If I move this cluster, the weights are derived from the ramp. The trick at this point is to get the ramp changes to affect the thing. So if I move this, it changes the color, but it doesn't change the way that the ramp is working, unless I hit edit, and then it'll suddenly kick it. So the problem with this is that it's not as complicated as it seems. Basically, Maya works by piping information through nodes, kind of. I mean, it pipes information, and it only pipes what it needs. So you have to tell Maya that for this expression, since we made it ourselves, you have to tell Maya when to switch this expression up, or when to go ahead and evaluate, because you can see that at this point nothing's happening when I set this. Like it's not telling me it's evaluating, which is what we had printed here. So what we have to do is have one little line at the top of this to set it off. It doesn't have to do anything, so we'll call it vector dummy equals mid control ramp dot out alpha. Doesn't have to do anything. It makes one little connection on the input, but it has to be something that would change anytime we want the output to change. If I set it to just some random variable in the scene, then if nothing about that variable changed, nothing would happen. So it has to be the thing that kicks off the script here. So out alpha is not a bad way to do it. So at this point, if I grab the ramp and I set it to move here, now it's working. And it's typing evaluating out onto the thing here. So cool. That works every time anything here changes, because it changes the values. Excellent. This is what we wanted. So we're almost there. Let's do a little bit more just to make this prettier and work in a way that we can use it. Okay. So I'm going to get rid of this line and edit it, and we are done with the expression. Cool. So now we have to create a control. I'll create a circle here, and I will group it, and I will call it mid control and mid control group. I will move this group to the center here, and I will rotate this control, and I will freeze the transformations of this control. Good. So now this control does nothing, but if I take it here, I add the control and I add the cluster. I'm just going to hide all the shapes for now. I can combine, or I can connect these three attributes to the cluster. So now that moves. Now what I'll do is I'll add an attribute called position. And we'll just make it go from 0 to 1. Well, you don't have to do that. I'm going to do it a little differently. I like it to be 0 by default for the middle, and have it go between two somewhat larger values, because it makes it easier to slide it back and forth. Because I want to be able to not have to hold Control and Shift while I do that. So what we'll do is we'll create that to be like that, and then we will node editor create a set range to mess with it. So we'll do set range mid control set range. If you didn't know already, set range takes an input value range and puts it normalizes it to another range. So if this position goes into value x, we can see it's currently at 0, and it goes from -10 to 10. So if I change the old min to -10 and the old max to 10, then the new min and max will go from 0 to 1. Cool. So we will take our ramp, we will add it to the field here, and we're gonna right click it and show all attributes, and go to our color entry list. And these indexes don't necessarily equate to, the setup. This could be 2 and this could be 1, which is actually the case. But the way to check to make sure that you're set up correctly, if you grab this and move it, it'll show up in your script editor as index 1. Index 1. Okay. So that's what we want to connect to. Index 1, out value x goes into the position. You can see that didn't work correctly. For some reason. Oh, no, it does work. It's just this is set to 10. There, now it's in the middle. So what we got now is this moves back and forth. The control does not, though. So how are we going to do that? First of all, let's fix this thing. When it gets to the end here, it snaps, and that's just because the ramp here, when it overlays like that, one value takes precedence. So the way to fix that there's two pretty good ways. One is you can have point 0 being your midpoint, because that will take precedence over sort of both of these. Or point 2, yeah, point 0 takes precedence over both. So, but the other way to fix it from this point is to just take this and make it 0.01 and take this and make it 0.99. And that way it will never quite reach right on top of the other one. There we go. That looks pretty good. Cool. Next thing we're going to do is set our control to follow the position. So, how to do that? I'll show you guys the complicated way because hopefully you guys will learn something about this stuff. Alright, so the control works. We got movement, we got position. The control does not yet follow the thing, so what we're going to do is we're going to connect this control's parent, which we can do because there's no constraints involved, it's just piped directly into here. We set this control's parent to this surface. We can sort of slide it along where the surface already is, and then we'll do something cool like that. You could also just, depending on how complicated your setup is, you could also just have the set range node go from, for the position output, go from, okay, we're at 5 here, so it's between 0 and 10. So if I set this group here, if I put this into value y as a new thing, and from -10 we will set our range from 0 to 10, then I can take the output value y and put it into translate x here, and that will do basically everything that you need, as long as sort of this setup doesn't change. And there's a bunch of ways you can go about trying to get this constrained, but at the very least I think you guys might find this kind of cool and useful for other projects. Anything that you might need to change the natural setup for your control, this is a pretty good way to do it. So what we'll do is we'll constrain it down, well, not constrain it. We will go into our FX settings, go to N hair, create hair, and we'll just do 1 and 1 for U and V onto the surface, and we'll create a hair follicle here. Kind of see it. We'll get rid of our output curves, our nucleus, and our hair system, and we'll just call this control group. We have one follicle here with one extra transformation node inside, and all we have to do is take our control group and put it in the follicle. Now when you move this, it's getting a double translation. When you rotate it, you're getting a double rotation, but we can fix that. Really quickly though, the point of that was that we can take the same position output that we got from out value x and put it into our parameter v, like that. And now when we change our position, it slides the control along. But we need to fix the double translation. And to do that, we need to neutralize our own controls rotation. Yeah, controls rotation and translation. Technically, you don't have to neutralize the rotation. You can just sort of unlock this and break the rotation connection to the follicle that's on the follicle here. And that actually works better because then when you get to this point here, it won't try to rotate it this direction when you get to the end here. But just really quickly as a demonstration, if I take the control and I parent it twice, and we'll call this rev rot, and we'll call this rev trans, I can go into my node editor, start over here, get that in there and that in there. We'll put in a multiply divide, and I'm doing this really quick, so I'm not going to rename anything. Output to translate, set this to multiply the translate by -1. Then at this point the translation is effectively neutralized. So we don't get the double translations. We don't get double rotations either because we broke that connection, so that doesn't actually affect us. But if we wanted to make it so that this does not rotate, just for future reference, it's very similar. Duplicate this. This is already set to -1 on the input 2. So we put that in there, put that in there. So here we are. So now, when you rotate it, it's not supposed to rotate at all, but you can see it kind of is. It's kind of freaking out a little bit. And that just has to do with the rotation order. So the way to fix that is to just take the rotation order here, XYZ, or XYZ, and take the rotate reverse group here and change it to ZYX. Perfectly stable. Yes. By the way, the cluster freaks out if you rotate it too much. That's just clusters. I got no way to fix that. I think it has to do with the way that it sort of changes the sort of rotation to a vector. It works pretty okay up to a certain point, and it gets kind of crazy. So you might have to put some limits on your cluster. Anyways, that's that. We're actually going to get rid of that because I don't think we need that setup. What just happened? Okay. Okay. That's fine. Whatever. I'm just going to set this to 0. It's still going to be there, but it's not going to do anything. Okay, cool. So now we have a sliding position, back and forth. And all we have to do is, now we have to get the rotation to work. Because the cluster isn't actually moving, as you may recall. It's just sort of staying static, and the weight of the cluster is moving. So how to get that to rotate correctly? This is also... So what we do is we take the cluster here, the cluster handle, I should say, and we're taking the set range that we used before, and we are going to open up the cluster handle, show all attributes. Dang, there's a lot of things here. And what we'll do okay, this is a little tricky, but what we'll do is we'll take the out value y that we got from here by taking -10 to 10 and changing it from 0 to 10, which is sort of the x dimension across here. This is 0, this is 10, but the values here, that's -10 and 10. And we're going to put out value y into scale and rotate pivot x. And there, like I said, there are multiple ways to do this. I'm still sort of working out a way to keep it from cycling when you put it in with your other stuff, but for the purposes of this tutorial, we are set. So it rotates from the right point. The cluster is still over here, but if you select it, its rotation pivot is now over here. So that's kind of cool. If you change the position, you get some interesting kind of effect going here, but it's accurate to what you are actually technically doing, which is moving basically the pivot point of your pivot point and the effect range of your control. So there you go. Yeah, that's pretty much all of it. There's all sorts of little things you can add to this, and I trust that you guys can probably figure it out. For instance, if you wanted to mess with the scale of the ramp, all you have to do is sort of have some controls going into the position of the 0 and 1 color entry list here. So you could have a value that adds position and subtracts from position in the same rate, and it would just sort of pull this in, and then you get sort of a nice kind of scaling effect going. You can plug something into the interpolation here to change its setup, sort of the interpolation. And you can even take values in between. You can even plug nodes in between this expression and this cluster. So you can see that there's 30 inputs and 30 outputs. If you wanted to, you could create a gamma node in between all these. Okay, so as an example of what I was talking about, I just threw this together sort of out of what we were working on there. And what I have is this sort of VSC sort of stands for just like the sort of form of the curve, like V being kind of a sort of a straighter line, S having 2 or maybe 1, being sort of a curvy line, and C being more of a C-shaped curve. And the way I did this, there's a couple of different ways that you can go about this. When I started, I did it by actually doubling up the whole thing and creating 2 different ramps. So there's 2 ramps going in here, and it just does the same expression twice, one for each ramp. And then I set the values of just a basic node with some custom attributes on it. So if I bring that up, if I can find it, these 2 ramps here. Yeah. So all of them go into, for one ramp goes into here, into these values, and they're just pretty much in here as the expression. And all the other ones go into this one. And then I have a blend between them, which works pretty well, and all the blend input attributes are controlled by my controller. And then I have another set of attributes that changes the interpolation. So when I stack all those together, what I have is sort of these values that are keyed here. This is the interpolation for the second ramp, this is the interpolation for the first ramp, and they're numeric values because I was lazy. When I move this, once it gets to 1, the blend gets to the second ramp, and then it switches the interpolation for the first ramp and starts interpolating and starts blending in the other direction. And that way you can have 3 different setups. I also have gamma nodes connected to the end of these, and that gives you just a little bit of extra control. And actually, if you wanted to, you could have just one node going in and then just use the gamma, because the gamma is actually pretty cool. If I just change this, if I go to my S-curve here and I mess with the gamma value, I can get pretty much a lot of the sort of close to the same sort of interaction. Push it out, pull it in, sort of thing. So I can scale my ramp in, and I do that with just an add subtract node. This one, plus minus average. Wow, this is a mess. Okay. So yeah, what it does is it takes the value of the position, and then it adds the value of the ramp to one side, and it subtracts the value of the ramp to the other side. So when I pull it in, it has, you can see if I subtract the ramp scale, it pulls it in this direction. So yeah, position all that still works. And yeah, there's a lot of stuff you can do. Okay, one last thing. In the spirit of exploration, I've also sort of attempted the same sort of setup, but with a softmod node. Some cool things about the softmod node is that a lot of the stuff that we've been working on with the clusters sort of come native with softmods. You get a fall-off radius, and a fall off center that you can move around, which sort of takes the place of our position and fall off. I can change this to this value. And sort of what ends up being the problem is that when we get to the edges of this thing, it just sort of rams into them, and the only reason it doesn't push these last values up is because they're not weighted to the soft mod. So I hit the edge and it just kind of doesn't look that great in a lot of ways unless you kind of finagle it. So it's a little harder to get the shape that you're going for, but in terms of ways to go about this that give you the sort of functionality that you're going for, but without as much of the sort of computational cruft or whatever, this isn't a bad way to do it. And it's pretty much the same basic setup. You got the soft mod, which is very much like a cluster. As you change the position, the soft mod's rotate axis moves along with it. And in order to get the different shapes, which I'll just show you really quickly, I just have static values going into each of these different fall-off curves, and the static values I actually did get from a ramp using pretty much the same sort of script. You do color at point, and then it just sets the value, sets the attribute onto just an attribute that you add to this thing. Just any node really, just a settings node. So now actually at this point I could change some of these. So I think we're in the C section here. So yeah, I can mess with these now, but sometimes if you grab them using the ramp, it looks a little smoother. It's pretty difficult to get them to look that good otherwise, so that is an option. So I hope you guys enjoyed the tutorial. I know it was a long one, but there's a bunch of sort of nuggets of information that you could use in various ways. So yeah, tell me what you guys come up with. Let me know if you have any suggestions or if you have any questions. Just leave a comment or shoot me an email. I'm perfectly happy to get a conversation going about rigging or whatever. So yeah. Cheers.